time with this. You guys have not had a hard time with certain things that other students have. It's called chain rule. And I don't know why students have a hard time with it. Maybe students have a hard time with this because they take Calc 1 and then they take Calc 1 again in college. And they didn't really understand the chain rule. They think they understood the chain rule, and so you're trying to undo things. Maybe that's the reason why. But let's see. We'll experiment here and see if you guys have a hard time with it, because I don't think it's hard if you follow the procedure. So the derivative, like if you have two functions, and it's going to become clear what I mean by that when you see an example. One inside the other, then the derivative of the outside, the derivative is the derivative of the outside function with the inside function plugged in for x times the derivative of the inside function. So it's a little complicated to memorize it, but once you see me put the pieces together, it's just a procedure and you assemble the pieces. So for example, if I have the square root of 5x squared plus x, what's the inside function of that? So everybody knows what I mean when I say inside functions. The garbage that's inside there, 5x squared plus x. So the inner is 5x squared plus x. What's the outer? How do you find that? Well, you cover up the inside with your thumb and replace your thumb with an x. That tells you what the outside function is. So I couldn't put a picture of a thumb there, but you replace, just cover up the inside with a thumb and then replace your thumb with an x. So you get, that's the outer function. And in calculus, we always write x to the 1/2 because of that first rule, n times x to the n minus. I want to apply that rule at some point. So out of habit, I'll always put it x to the 1/2. And then step 3 is assemble all the, Brittany, did you have a question?
Yeah. Can you repeat what it is?
I wrote it up here. I'll be posting this too. It's the derivative of the outer function with the inner plugged in it for x, and then times the derivative of the inner function. Then you just take the pieces of what you need, like all those things that I just said. You need the derivative of the outer and you need the derivative of the inner. So find them. Derivative of the inner is 10x plus 1. Hopefully I did that correct. I can't see it anymore. And derivative of the outer function, I did this really slow. You're subtracting off minus 1 from a fraction. So 1/2 minus 1 is really 1/2 minus 2/2, which is minus 1/2. So those are the derivative of the inner and derivative of the outer. And then you plug in to the chain rule. The chain rule says take the derivative of the outer function and instead of the x, plug in the inner. So because I don't have my dynamic PowerPoint, I wanted you to see the two-step process. There would be an x there when I first took the derivatives up on the previous sheet. You see that 1/2 x to the minus 1/2. But instead of the x, you're going to plug in the inner function for x. The inner function I already found was 5x squared plus x. It was identified on the previous sheet. So I plug in 5x squared plus x in for the inside. And then I multiply by the derivative of the outer, which was 10x plus 1. So I think the reason the students in Calc 1 have trouble with this is because they didn't, I don't know, they do it slow, obviously, in high school, but they somehow memorize something that is sticking in their head that's incorrect. If you follow this, you will not get it wrong. There's no way to get this wrong. So for example, if I have to find the equation of the tangent line at x equals minus 1, well, I find my y1 first, like before, it was 2, and I made this up, and the numbers usually don't turn out nice, so I'm kind of surprised they did. It was an accident, I promise. Then y minus y1 equals m times I, just the same old, same old. How do I get the m? I plug it into the formula for the derivative, which is still at the top. So I plug in minus 1 for x in the formula for the derivative that's at the top, and I get, hopefully if I did my math arithmetic right, I get minus 9/4 for the slope. And then I plug that into y minus y1 equals m times x minus x1, and I get minus 9/4 minus 1/4. And you see the way I deal with fractions when I don't have Maple or something sitting in front of me. Not very well. I think my 3rd grade teacher would fall over if she knew that I got a PhD in math. Because that's what they count, right? If you do everything perfect on your arithmetic. I wasn't very good at that. It's a lot of bookkeeping. Okay, so let's check this on Mathway. I'm afraid to check it because that was a lot of fractions and minus signs, both of which I am very highly bothered by. Minus 9/4 x minus 1/4. That's not nice. And does anybody remember what the first, it was something like square root of, what do I do, click this thing?
Yeah.
Okay. And then, what was it? Please be right, please be right. Let me erase this. Something's not right here, okay. It didn't like what I put in, because this shouldn't be here like this.
It's minus, supposed to be outside for 9.
Yeah, it's minus 9, yeah, that's the same thing. So, I don't want to refresh this because I don't want to type it in again. So, I think this is it. I think the blue is the, this shouldn't be here for some reason, but this and this are overlapped, so it does look like a tangent line. I don't know why this is here. I'm really happy that this stuff is free, but I do see the difference between my $10,000 computer software program and this. So I guess you get what you pay for, and this extra line is there and it shouldn't be there. So this looks correct. At -1, it does look like the tangent line. Huh? What?
You paid $10,000.
No, either the university has it as a license, or I get it through a grant if they don't have the license. Yeah, but a private user, the private users, they charge $10,000 and they police that thing. You think you can't police the internet? They police it. You know, it's really hard to get a pirated copy of something like that. MATLAB, MATLAB, Maple, those software, their bread and butter is using it in education or using it for research. All right, so that is it. And